Hi, boys and girls. It's Miss O'Donnell here. I'm super excited to see all of you. And you know what? I'm actually more excited. But please do not tell Miss Meininger, who I know visits many of your classrooms. I'm super excited that Penny Jar and Towers are over. And super excited for decimals. Decimals are really exciting to me because they kind of help us build on our understanding of fractions. So today we're going to practice reading and writing decimals in tenths and hundredths. And we're also going to be using models to help us represent decimals as tenths and hundredths. I know it might be pretty tricky because really we were off Monday. So it's really only our second day with decimals, but hang on and join me. Go grab a pencil, go grab your notebook, your napkin, your paper plate, whatever you're using as a great mathematician to show your work, and then come back and join me. Okay. So I have a pretty serious question today. I'm a little nervous to ask because I don't really know what to do myself, and I'm hoping that you could really help me out with this. The question today we have is, how can we represent 3/10? 0.3. I say that as 3/10. Say it with me. 3/10. I'm also going to write it out for you to see. It's not 3/10. It is 3/10. Yikes. But now I'm going ahead and I'm looking here at my model. Yikes, but when I look at this model, 3/10. When I hear 3/10, this makes me think of fractions. 3/10. 3/10, which means that if I had a model and I cut it into tenths, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would shade in 3 pieces for 3/10. But that's how I show it when I have a whole that's broken into 10 parts, but I don't really know how to show 3/10 on a model that this definitely does not seem like it's tenths. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks like a square. I'm thinking there's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it makes me think that there is 100 total pieces. Because I know 10 times 10 equals 100. I'm already starting to think, how could I show 3/10 is equal to something on this model? I don't really know. Let me think. As I'm thinking, I'm knowing 10 times 10 is the 100 squares that I saw on my grid. And I'm starting to think that, 1/10 of 100 is 10 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be 1/10 of 100. And then 20 squares seems like 2/10. And 3/10 would be 30 squares. So that means 4/10 would be 40, and I can continue. 5/10 would be 50, and 50 squares would be half of the 100 squares, and 5/10 I know is equal to 1/2. I would have 6/10, 7/10, 8/10, 9/10, and then 10/10, which is equal to 1 whole. So I'm already starting to think and make a prediction that 3/10 would be equal to 30 squares. So I'm going to go ahead and shade that in. So I'm starting to think that 3/10 is equal to 30, and then the whole would be 100. So 30/100ths. I'm thinking that because when I see the relationship between 3 and 30, I can multiply the numerator by 10. And then if I multiply the denominator by 10, 10 times 10 does get me to 100. So it seems like 3/10 is equal to 30/100ths. Wow. Now we're going to take a look at 3 more decimals. 5/10, 7/10, 8/10. It's going to be our job right now to write each of these decimals as tenths and hundredths in fraction notation, which means that a fancy word basically for we're going to write them as fractions. So 5/10. Sounds like when I have been working with fractions, 5/10. So it sounds like 10 is going to be my denominator, and 5 would be my numerator. 5/10. Then if I move over and I have 7/10, I wonder what's going to change between 5/10 and 7/10. Well, the tenth will stay the same, the denominator will stay the same, but the numerator is going to change from a 5 to a 7. Can you do the last one on your own? Go for it. Wow! You did an amazing job. If you said 8/10, give yourself a pat on the back because you were able to see that there was almost a pattern here. With tenths, I have 10 as my denominator, and then I look here at the place value that comes to the right of the decimal point, and I see that's the tenths, and that becomes my numerator. Nice work.